For most of history, tools were static. A calculator never improved at math on its own, and a hammer didn't learn to hit nails. Any improvement required a human to manually build a better version. Early software followed the same rule. It executed the specific lines of code it was programmed to run, doing exactly what it was told and nothing more. This is the baseline for human innovation, a straight, predictable line where a set amount of labor yields a set amount of progress. But inside the labs building modern artificial intelligence, that linear relationship is beginning to break. Engineers are now pointing AI systems inward, using the current generation of technology to help design, test, and write the code for the next. This is recursive self-improvement, a cycle where the technology becomes an active participant in its own development. In this loop, the time required for a tool to improve is no longer limited by how fast a human can work. This shift is already measurable inside modern development environments. 2 years ago, AI-written code was near zero. Today, AI writes over 80%. Individual output scaled too. Engineers ship 8 times more code daily. In one case, an AI autonomously pushed 800 fixes at once. That single deployment reduced a specific class of errors by 1,000-fold. To complete that same volume of work, a human engineer would have needed an estimated 4 years of manual coding. A single engineer's capacity now scales through the machine's own output, effectively turning 1 day of oversight into years of technical progress. As the software improves its own architecture, its ability to handle complex, long-form work expands. The length of a task an AI can reliably complete on its own has been doubling roughly every 4 months. 2 years ago, these systems could handle tasks lasting 4 minutes. Today, they execute autonomous workflows that take 12 hours. There are caveats. Lines of code are a limited metric for actual intelligence, and these systems still require human oversight to function. However, the human role has shifted. Instead of writing step-by-step instructions, engineers provide the high-level goal and let the AI determine the method of execution. The critical skill is no longer the ability to write the steps, but the ability to judge whether the result is correct. The work has transitioned into a role of navigation. The engineer defines the destination, while the machine handles the mechanics of the journey. These mechanics are moving beyond the labs and into the broader economy. When AI builds better AI, each subsequent generation arrives faster than the one before it. This is compounding progress, where growth multiplies rather than adds. This allows a 100-person company to achieve the output that previously required thousands of people. Every employee now operates with a stack of AI assistants that are themselves being improved by the very work they perform. Raw intelligence and access to information are becoming secondary to the speed of implementation. The primary bottleneck is now how quickly an organization can deploy these self-improving tools into their daily operations. The compounding has already started. The gap between those utilizing this cycle and those relying on linear growth is widening in real time.